Hi everyone, my name is Parth and I'm here with another video on OOPs concepts. So let's get started. So first we'll talk about some features regarding object-oriented programming, which in short is known as OOPs. So OOPs is a programming model where programs are organized around objects and data rather than action and logic. So like when we are trying to write any code or any program in an object-oriented programming model, everything inside that code is a object and we store data inside those objects rather than any logic. The second feature is object-oriented programming allows decomposition of a problem into a number of entities called objects and then builds data and functions around these objects. So what happens in case of object-oriented programming model? Everything we code is basically inside a blueprint. That blueprint is known as a class, and everything inside class is an object. So if you talk about any, suppose a property, integer property or a string property, those are simple objects. And then we are storing data inside these objects. The next point is the software is divided into a number of small units called objects. The data and functions are built around those objects. So as mentioned already, everything inside the class is an object. So maybe a class can have number of properties or methods, and we are storing some data in those properties. So basically, we mean to say that whatever logic or whatever data we are storing, that all those things revolve around the objects. Next is class. So a class is the core of any modern object-oriented programming language, such as C sharp. So by core, we means that it is the starting point, you can say, of writing any code in object-oriented programming language, such as C sharp or VB.NET. So basically, class is nothing but a blueprint of an object that contains variables for storing data and functions to perform operations on the data. So as I mentioned already that a class basically contains fields, properties, methods, events, indexes, etc. So the variables or properties we declare are used for storing the data, and the methods which we write inside the class are used to perform some operations or some logic on that data. A class never occupies any memory space, okay? Because it's a logical representation of data. It's not stored physically somewhere. So you can see an example of class, the syntax, and you can say a simple example. So we declare a class by using the keyword class, and then we followed by the name of the class. Like in this example, we have a class which has a name employee, followed by we give the curly brackets. And inside this curly brackets, we define everything like variables, functions, any logic, any properties, etc. Next is object. So objects are basically used to access those features which are there inside a class. So basically these are created on the runtime. When you run the application and you're trying to access a function or a field or a property of a class, objects are used for that. So they represent basically a person, place, or any item that the program must handle. So basically we say that an object is an instance of a class. So here on the right hand side, you can see that we have class car. It has three properties: model, its year of manufacture, its color. And we have three functions which define some logic or some operations. We have start function, we have move function, and we have stop function. So basically the properties are known as data members, and start, move and stop are the functions. So when we want to access any property or function of this class, which is car, we create an object of this class, which is car. So since already mentioned that the class does not occupy any memory space, since it's a logical representation. So in order to work with the data or features which are given to you by the class, we must create a variable for that class, which is nothing but an object. So you can see that we have a class employee, and the syntax to create an object of a class is you give the class name followed by a variable name, then you put equal sign, then you use a new operator or the new keyword followed by the class name and the brackets, and then we terminate the statement with a semicolon. So here in this example, we have a class employee, and we create the object like this: employee, which is the name of the class, followed by objemp, which is a variable, equal to new keyword, followed by employee bracket and semicolon. Next comes abstraction. So abstraction in layman terms is to represent the essential features without representing the background details. So like when you want the user to just look at the, you can say what features are we providing inside the class without knowing what is happening in the background. That is known as abstraction. So basically abstraction lets you focus on what the object does instead of how it does it. So like when someone is trying to use that class or use the functionality, so they know what the so they will know that what the class is doing or what functionality it's giving them, but they will not be aware of how it is doing that in the background. So for a simple example, let's say if some doctor gives you an application to fill in the details, you will provide the details, right? Like name, age, address, date of birth, blood group, height and weight. So here age, name and address. So you can create a class for that. Okay. This is known as an abstract class. The class is not complete and it can be inherited by other classes. So abstract class is basically used or is basically created when you want to inherit some common data into multiple child classes. Like in this example, you have multiple students. So you can have multiple child classes for each student, and you can have a common abstract class which will have a common details for every student like age, name and address. And then you can inherit this abstract class into multiple child classes. So let's see another example of abstraction in terms of coding. So you have an abstract class mobile phone. So as we know that every mobile phone has at least two major functions, which is to make calls and other is to send the messages. So we have an abstract class here, mobile phone. Inside this class, we have two functions, calling and send SMS. So abstract class basically has methods which are normal methods as well as abstract methods. So now we have three child classes: Nokia 1400, Nokia 2700, and BlackBerry. So if you see the first class, child class basically, Nokia 1400 is inheriting this mobile phone. So both these methods, calling and send SMS, will be available to the Nokia 1400 class, and it can override this functionality or implement the logic as it wants. Then we are inheriting this mobile phone class into the second child class, which is Nokia 2700. Apart from these two methods, calling and send SMS of mobile phones, Nokia 2700 class has three additional features like you can say FM radio, MP3 player, and a camera. Then we have a third child class, which is BlackBerry. So it has numerous other features apart from the ones it is inheriting from mobile phone. So it has FM radio, MP3, camera, recording, read and send emails as extra features. Next comes encapsulation. So encapsulation in a layman terms is wrapping up of all the data members and the functions together into a single unit or into a single capsule is known as encapsulation. So encapsulation, like let's say an example, is like your bag in which you can keep your pen, book, etc. It means that this is the property of encapsulating members and functions. So here you can see an example. We have a class which has the name bag. It has some, we can say properties like book, pen, and it has a function, read book. So this encapsulation of properties and functions inside a capsule or a single unit is known as encapsulation. Encapsulation basically is used when we want to hide the internal details of an object from the user. So basically when we hide the data for security, such as by making the private variables and exposing the properties which are public to access the private variable that will be accessed outside that class. Here you can see we have a class demo. So we have defined a private variable mark. Then to access that variable outside the class, we have defined a public property for it. Then this property will have the accessors get and set. So we define basically a public property so that outside classes or users can access this private variable, which is mark. In layman terms, let's see two examples of encapsulation. First is example of mobile phones and mobile phone manufacturers. So suppose you are a mobile phone manufacturer and you have designed and developed a mobile phone design. So this is basically a class. Now, by using the machinery, you are manufacturing mobile phones. So the machinery means whatever functions you have created or properties with which you are using, basically the objects for selling. So when you sell your mobile phone, the user only gets how to use the mobile phone, but does not know how the mobile phone works. Next example is an example of TV operation. So it is basically, if you see a remote, it is encapsulated with a cover and we can operate it with a remote, right? So there is no need to open the TV to change the channel, right? Because we have a functionality given to us in by a through a remote. So we can change the channels in a TV using a remote, and there is no need to open the TV to change the channel, right? Next is inheritance. So when you want a class to inherit another class or to include some features of another class, it's known as inheritance. So the class which is inheriting the other class is known as the child class, and the class which gets inherited is known as the parent class. So here you can see we have a parent class, name is parent class, then it has a constructor, and then we have a method parent. So it's parenting a value, I am a parent class. Then we have a child class, then we are inheriting this parent class. In order to inherit a parent class into a child class, we use colon operator. So as you can see, we are inheriting parent class into the child class, right? And then child class also has a constructor. And then we are basically calling the child class from another method, which is main, by creating the object of the child class. And since we have inherited the parent class inside the child class, we are able to access the print method of the parent class using the child class object. So this is known as inheritance. Next is polymorphism. So polymorphism in layman terms means many forms or various forms of a single object. So we can take an example of a mobile phone. So mobile phone is one name under which we have many forms, like it can be used as a phone, it can be used as a camera, it can be used as an MP3 player, it can be used as a radio as well. There are basically two types of polymorphism. First is static or compile time polymorphism, also known as early binding or method overloading. The second is dynamic or runtime polymorphism, also known as late binding or method overriding. So first is static or compile time polymorphism, also known as early binding. So example of this is method overloading. So in method overloading, what we do, the basically in a single method, in a single class, basically, we have multiple methods. All the methods have same name but different signatures. By different signatures means, as you can see on the right hand side, we have a class test data and a class program. So inside class test data, we have two methods with the same name add, but their signature is different. So as you can see, in the first add method, we have three parameters of integer type. Whereas in the second add method, we have two parameters of integer types. So there is a difference in the signature of the method. And then from our main method, which is inside the program class, we are calling the two methods by creating the object of test data class. Next is dynamic or runtime polymorphism, also known as late binding. So method overriding is an example of dynamic polymorphism. So here, the method name and signature, which means the number of parameters and the parameter types, are same, but they have a different implementation or logic inside them. So you can see we have three classes: circle, square, and rectangle, right? So here you see that in each of these classes, we have a method name as area. And all these three classes are inheriting from a parent class, which is drawing. So they are overriding the method area of the drawing class. So if you see the circle class, everything is same in all the three classes. So in the circle class, the formula is 3.14 into math dot power radius comma 2. So the area of a circle is pi r square. If you move to square, the area of a square is length into length or side into side. And the area of rectangle is length into width. So you see we have the same name and signature of the method area, but we have different implementation. And then from our main method, which is inside the program class, we are creating the objects of three classes: circle, square, and rectangle, and we're calling the methods area. Thank you. I hope that you have liked this video and got a basic idea about the object-oriented programming features in .NET. I will see you in some next video. Thank you.